Hello everyone, welcome to my channel. Today we are going to discuss about trigonometry, which is intended for CBSE grade 10, IGCSE, GCSE year 10 and 11. So let's see what is trigonometry. Trigonometry is nothing but the measurement of triangles, and the word trigonometry is originated from Greek word trignon, which means triangle, and metron, which means measure. So in trigonometry, there will be two cases which we are going to discuss. In today's video, we are going to discuss about right triangle. So this trigonometry deals with right triangles as well as non-right triangles. So when we speak about right triangle, let's see, we must discuss about Pythagoras theorem, which is definitely very important. Otherwise, we cannot do any problems here. And then when we deal with the right triangle, we also deal with the basic trigonometric ratios, that is sine, cosine, and tangent. So there are six ratios, but we will discuss about the three basic ratios, that is sine, cosine, and tangent. Okay, and when we talk about the non-right triangles in trigonometry, then we have sine rule, then we have cosine rule, then we have area of triangle, and then it will be 3D trigonometry. So non-right triangles we will discuss in another video. In this video we will just keep it to the basics, that is about the right triangles, Pythagoras theorem, sine, cosine, and tangent. So sine, cos, and tan trigonometric ratios, these are our trigonometric ratios. So let's have a recap on Pythagoras theorem. So first you understand Pythagoras theorem is all about finding the third side. It can be the longest side, it can be the other two shorter sides. So let's see, how do we define the longer side? So in right triangle, everyone knows, yeah, this is your 90-degree angle, right? And side opposite to this 90-degree is always called as hypotenuse. Yes, you have to be careful about choosing the right side. So we say that this is longest side, but always make sure that it is opposite to 90-degree, then only we call it as hypotenuse. And these are the two other shorter sides. Okay, so let's take one example how to find the length of any of the sides. So first we will discuss about finding the length of largest side. So consider this triangle PQR, which is a right triangle. Let me mark it 90-degree. And then here it is hypotenuse. Okay, let me mark this as well. Then according to the Pythagoras theorem, PQ square plus QR square is equal to PR square. So let me mark this as 3 centimeter and this one as 4 centimeter. So what will be the length of hypotenuse? So let's see that. Okay, I will write it as like this: PR square equals PQ square plus QR square. Then I just input all the values. So you get PQ square will give you 3 square, QR is 4 square, and then PR equals 3 square plus 4 square, that will be equal to 9 plus 16, which is equal to square root of 25, and that is equal to 5 centimeter. So we got the measure of our hypotenuse, that is 5 centimeter. So in this way you can find, using the same rule, you can also find the length of shorter sides. So I will take one more example with the same measurements. So again consider this is your 90-degree and this is the known longest side, and suppose we know this side as well, 4 centimeter. Let me mark it as ABC. So it will be AC square equals AB square plus BC square. And now you see that we have to find this missing length. Okay, so what we will do, we just input the values. 5 square equals AB square plus 4 square, and then you transpose it, so you get 25 minus 16 equals AB square, and then we can have AB equals under root of 25 minus 16 is 9, and hence you get 3 here. So the length of side AB is 3 centimeter. I hope this is clear to everyone. This was the basic of Pythagoras theorem, which you are going to use extensively in this trigonometric ratios, especially sine, cos, and tan. Okay. Now let's discuss about the trigonometric ratios. So as I said, we are going to discuss about basic trigonometric ratios. Those are sine, cosine, and tangent. So, what is the use of these trigonometric ratios? So, what we can do is, with the help of these trigonometric ratios, we can find the side of a triangle, we can find the side of triangle or angle when other two things are given. So, I'll show you how. So, suppose this is your triangle, okay, and 90-degree right triangle, and suppose if you know this angle, and then you can find any of the sides. Suppose as okay, let me take this. Right now we have everything here, so suppose one of the thing is missing. Okay, let me say I have to find this measure. Let me mark ABC. If I have to find the length of side AC, I can find this length with the help of sine, cosine, and tangent ratios. So let's see how it works actually. So before I explain you sine, cosine, and tangent, you should be able to mark your triangle properly. This is very, very important, marking the triangle properly. So understand it. How do we mark it? So let's say this is your triangle A, B, C, and let me mark another one. Okay, I'll mark this also as A, B, C. 90-degree is here and 90-degree is here as well. Okay, now I will mark angle here. Okay, so let me say this is angle X. Hmm? And in this triangle, I will mark my angle X. Let me mark it as Y. Okay, now what you have to understand is which is hypotenuse, which is opposite side, which is adjacent side. So let's see how to work on this. Now, in this triangle, you have angle X here. So we have to mark opposite and adjacent with respect to this X. So opposite to 90-degree is always your hypotenuse. So let me mark it as hypotenuse. So this is hypotenuse as well. And now if you see, angle X is here, and very clearly you can see that opposite to this angle X is this side. So this is my opposite with respect to this angle X, and this side will be adjacent with respect to this angle X. I hope this is clear. And when I take this triangle, this is angle Y, and opposite to angle Y is this. So I will mark it here opposite, and adjacent to angle Y is this side. I hope this is clear to everyone how to mark the triangle. If you do this wrong, definitely you are going to do this wrong, and the whole question or your solution will be wrong. So this is very, very important to understand where we have to mark hypotenuse, where we have to mark opposite or the adjacent. I hope this is clear to everyone. Okay, let's do, yeah. Now I will introduce you the sine, cos, and tan ratios. So sine, cos, we also call it as cosine, and tan, we also call it as tangent. So there are certain rules for this. Sine is opposite upon hypotenuse, Your cosine is adjacent upon hypotenuse, and tangent is opposite upon adjacent. So you might forget, or you might look for some shortcut to remember this. So there is a mnemonic. So ka to a. You can always remember this. So this stands for sine is equal to opposite upon hypotenuse. So you can see like this. Sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. So we can learn it this way, or you can learn it this way also. See, suppose like this, here we have sine, this is your sine is opposite upon hypotenuse, and then this is ka. Cos is adjacent upon hypotenuse, and then we have tan here. So this is your T and O upon A, that is opposite upon adjacent. I hope this is clear. You just remember these basic three ratios and everything will be clear. So you have to understand how to mark the triangles, the correct opposite and adjacent. See, now you might understand, okay, why I said this is important to mark it properly. And based on this, you can use your trigonometric ratios to find the missing length or angle. Okay, now let's take one triangle and we will write all the ratios, like all these three trigonometric ratios for this triangle. So this is 90 degree, and then let me mark this one as I can say this is uh, 70 degrees, and then again I will take the same length 3, 4 and 5, and let me mark my triangle as well, ABC. Now we'll write the sign for this triangle, sine ratio, cosine ratio, and then tangent. You can always write in short sine cos tan. Okay, let me write the formula for this. Sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, tan is opposite upon adjacent. Now let me mark opposite, adjacent and hypotenuse in my triangle as well. So if you look here, my given angle is 70 degree and the opposite to 70 degree is this. So I will say this is opposite, and adjacent to 70 degree is this one. So I'll mark this as adjacent, and obviously opposite to 90 degree is your hypotenuse. I hope this is clear to everyone. And now based on this marking and the formula for these trigonometric ratios, I can write the value. So opposite is 3, hypotenuse is 5. So sine is 3 upon 5, and I should actually mark the angle as well. I should mention the angle. Sine 70 degree here, and 70 here, and tan 70 degree here. Okay, so this will be, cosine will be adjacent upon hypotenuse. That will be 4 over 5. And tangent is opposite upon adjacent. That is 3 over 4. So I hope this is clear to everyone. This was with respect to this angle here. And now I will give you one more example with respect to, I'll change the place of given angle. So let's say here it is marked as theta. Theta is your unknown angle, okay? And then A, B, C, and this is 90 degree. And again I will mark it as 3, 4, 5. Now let's write sine theta, okay, then cos theta, and then tan theta. Okay, now before I start solving this, let me mark which is hypotenuse. So opposite to 90 degree is always hypotenuse, and opposite to the given angle with respect to which we are solving we have to mark the opposite. So opposite to this theta is this line BC, and adjacent to theta is this AB. Okay. Now we will mark our trigonometric ratios. Let me write the values. So you remember, sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. Now I will write the values. So opposite is 4, hypotenuse is 5, so this will be 4 over 5. And cos is adjacent upon hypotenuse, so this is 3 over 5. And tan is opposite upon adjacent, that is 4 over 3. I hope this is clear to everyone. Yeah. So we can use these ratios to find, suppose if you are given this length and this length, you can find this angle. Or you, when you are given this length, then also you can find this angle. Or if you are given this length, so whatever two lengths you are given, you can find the missing angle. And suppose even if you are given one angle and another length, another side, then you can find the third side. So it is always you are given two things and you can find the third side. Hope you find this video useful, and in the next video we will do few questions based on sine cos tan, and also we will work on our non right triangles. Thank you for being till end.